start off this morning welcoming Dagen, who's going to do emulators. You're doing it all wrong. Thanks, Dagen.
Thanks, everybody. That's not the best title, and I had a bunch of other titles that were equally corny and dad jokey, so my wife loves that about me. And so, yeah, I want to start today actually by, again, thanking all of you for coming here. This is a project I've worked really hard on for quite a while. Yeah, I think we're a little heavy. And, man, I'm yelling this morning. Can you guys hear okay? All right. So yeah, it's something that I've at least spent a couple of months on and not exactly what I intended to work on, and we all know how that sort of thing goes. So I really want to thank my family. My wife Kate is here, a little baby Theo. They helped a lot, and you guys know how it is. If your spouse or partner, they have to kind of put up with our weird hobbies, and sometimes this takes a lot of effort on nights and weekends that, so love you guys. And Theo has been doing code review for the past 3 months, so he wanted to see how it all came out.
Yeah, but how many PRs did we put in?
2, but they were just about licensing, and I was like, yeah. And oddly enough, I want to thank my manager, Kevin Seaman at Lexmark Enterprise Software, who's actually cool with me doing this and kind of knew when he hired me, yeah, I saw the story on TechCrunch, the little Flappy Bird game. And I was like, yeah, and by the way, once a year I kind of have this thing, it's something I got to do, and this doesn't count as vacation. It's kind of like a work thing. We talk about computers. So let's get into what I'm talking about. It's really 2 or 3 things. The first thing and how this all started was as an effort to modernize what was originally the KEGS emulator, pretty infamous, written by Kent Dickey. And now I've kind of got my own 2GS emulator project that uses that core. So that was where this all started. And now I've really veered off, and I'm trying to make 2 changes in the way that I'm trying to approach emulators. And I'd really like to get this message out that maybe people who are better at this and smarter, have better ideas, can have other ideas on how to do this implementation. Like, yeah, Dagen, that's a really good idea. Here's how you would really want to do it. But I'm a hacker. I got it done to where I'm able to get my proof of concept, and that's what you'll see today. So the first idea is that right now we treat emulators like applications, right? It's like a user-land app like Photoshop or Microsoft Word that just sits in front of you, and you're doing something there. Some people break that paradigm quite a bit, like the Internet Arcade, right? Or Internet Archive with all of their emulation projects, where it's a little bit more abstracted. MAME has an interesting abstraction layer. But the second idea is that I don't really like the way that we plug UIs and custom debuggers into the emulator application. That just doesn't seem like something that belongs there. The emulator should be this core thing that can run anywhere inside of an emulator environment and be that machine. So what we need instead is to be able to provide APIs to communicate with the emulator and be able to, most importantly, inspect any part of the machine at any time. Right? This is the advantage you can't always do with hardware. There are limits to hardware debugging, even if you have specialized cards and an I/O mapped memory space. You can't just read all the soft switches, or you will flip them. There's things like that. In an emulator, you totally can. Right? It's your code. You can do what you want. So you need to be able to do that, kind of communicate in and out to the emulator, and do that without disrupting the emulation. So hopefully that will give you a little guidance on where we're going, and if it doesn't, hopefully you'll just get it when you see it running. So that's the thing. I don't have slides. What I have is a bunch of live demos of very experimental code. So. And just a little personal perspective on me. Like I said, I work at Lexmark. I do a lot of work in, it's called cloud architecture, but essentially I build virtual data centers and network them. And my job, it really behooves me to automate everything, right? And be like, I don't want to do this again, so I spent the day writing a script to do it. Is that cool? And my boss is like, yeah, that's cool. So now what do you do? I just type in this name of the company and it builds that company. Okay, great. So I really am a big fan of that, and that's all enabled through things like having APIs that you can use to instantiate servers, having, you know, so much virtualized hardware out there. So that's kind of my professional background. What I wanted to do this year, instead of this project, what I like to do, and what a lot of us probably want to do, is write games and other cool programs for the Apple II. I'm not an emulator author. This is not my expertise. Though I have been a developer for many years in the past, so it's not like I can't program. It's just I wanted to write assembly for Apple II, not C, C++, various other languages. And when I write those games for the Apple II, I am very dependent on emulation. I have very fast iteration times, and I have a nice build environment. It's not super professional, but it's super quick, right? That's what matters. So emulation is the way to go for most of your development. And part of the reason you can't do it all on emulators is because they're not perfect. They're not the real hardware, so sometimes you need real hardware. But I think over time, we'll continue to close that gap, and that's why I do have a lot of hope in projects like MAME and MES emulators that are really doing it right. Like they're playing the long game of let's get everything out there, let's like document it all, and we'll continue to iterate and get it faster and better. But this isn't about MAME, it's about my emulator, which again is a fork of KEGS, very fast, but has some crusty old code in it. So before I kind of show you what I did to modernize the code, I think it would help people. I've never really shown how I build software, right? And you guys that do your own assembly on emulators probably have something kind of similar. What do we have here? Oh yeah. All right, so this, let me go back up one directory. First of all, can people see any of the text? Should I make it bigger? I think I can. Okay. Anyway, there's a directory on my computer. It's called Apple IIGS, and it's got a bunch of different things in there, and they're different projects. KFest, I think. Scrolled off the screen is Flappy Bird. Here's the Kansasfest Shirt, and this is just kind of how I typically organize things for. Essentially, think of these as code repositories because a lot of them are committed somewhere. This is actually a Google Drive. Anything that's worth anything gets committed to either GitHub or GitLab, right? So again, trying to pretty much practice modern development methods and have things like version control. So yeah, this is actually the Kansasfest Shirt. I always have kind of a source directory. You can look at the, which one is it? Sorry for the dinging. I still use VI a lot. I do use Atom sometimes for editing. So I've got this source in here. And this is a really simple program that you can just build with Merlin. You know, it builds basically a, looks like a Protoss sort of system file, except I don't have a quit routine in there, but it's assembled at 2000 because that's how I did the shirt, so I could have the 2016 layout. So if I have something like that, here's how I typically test it. I have a script called Brun. Cute, huh? But that's not like basic Brun. It actually stands for build and run, and if it fails, it won't run, right? Oops. Of course, I left something broken from last night. But that's actually a good example. So I'll go edit my shirt. Oops. If you're not familiar with VI, I'm just opening a different copy of this. I'm going to go ahead and copy what I had. All right. And fix the data that I had been playing with last night. To do this demo, I meant to revert it, and I didn't, but all right. So what I do, I just made a change there. I changed some data. What happened? Well, let's run it. All right, you get the picture? That's my build cycle. So let me show you the run thing really quickly, and then we'll kind of move on from all this. But this is sort of the it's showing my motivation here. That Brun script has something that's just called make bootable, runs Merlin to compile it, Merlin 32, OS X version. And if that is successful, in other words, if I get a non-error response, then it actually tries to launch my emulator. Oh, and in the make bootable, if the compile is successful, then it also creates a ProDOS image. And I'm using Cadius for that. I've used Apple Commander in the past, Java command line. And before that, I had a special fork of 2 Pro that came with KEGS, but I don't use that anymore. So if I were to run that make bootable, this is what it looks like. If you don't see it scroll by so fast, you can see the build for Merlin here. Creates a binary output, which I happen to turn into a ProDOS file so I can boot straight to it. And I have a volume here. I actually have a copy of ProDOS on here, and it knows to change the file type. So there's some stuff like that built in to kind of munge it. It puts all the source on there in case I want to open it in old Merlin. So that's all just kind of built in. But again, the real point here is that I can do this, and that's how fast my build is, right? It's just, I can't do this without an emulator and having a build system on a modern machine. And the alternatives now are not bad, which I could still build here, put in my USB drive, and go over to the CFFA, right? Yeah?
Quick question, you said you use Cadius?
Cadius.
Isn't that Windows only, or do you use Mac?
Yeah.
I checked out Mac OS X a little bit.
Did they not have one on their site now?
No, I haven't built it myself.
Okay. Well, one of us will take our home-built versions that we've changed. I meant to do that a long time ago. I'm so sorry.
No, I was like, I didn't know that was available.
Yeah. So, surprise release. I have Cadius for Mac OS X. Yeah, Olivier writes excellent tools, but generally doesn't have the time or really any knowledge about Mac, so he doesn't do it. So I don't begrudge him for that. He provides great stuff. I'm super thankful for Merlin 32, and we're going to probably keep cranking on that and try and keep these build tools going. Okay, so you saw I can make edits, and the one last thing I want to show that I'd probably, again, is just to kind of show motivation on why I did some things in my project a certain way. So if you saw that, really quickly it booted into GSOS to start ProDOS and run this little ProDOS app. Why do that? Because all of the Apple II software I typically write using a GS emulator, even for the 8-bit stuff, because I like having a very nice debugger that it's got called GSBug. Right, so now it boots into GSOS, loads the GSBug CDA, and then I have whatever the set start in it, just points to whatever my ProDOS thing is. So I can do different things. I can either put breakpoints in my code and have it break at specific things, or do what I just did, which is like a 4-finger salute, Control, Option, Command, Escape. And here I am in my debugger. I can hit S, and you can see where I'm at. If you look up at the top, you've got all your CPU registers. So obviously I'm still close to 2,000. It's a very small program. You can see A, X, Y, the emulation bit, so you know kind of your width. This is in stepper mode. It's your upcoming disassembly. So if I hit spacebar, this will be the next instruction executed. This is the stack, right? Page 100. We're at 1F9 now. Moves that way, or sorry, moves this way. But it kind of scrolls up though. You can see where it wraps around actually from 100 to 1FF. I really like it. It's pretty good. You can also monitor memory points, which is great. So I can say, watch this 0-page pointer, or watch a couple of them. So again, this is super helpful for my debugging. I never had a hardware debugger back in the day. Maybe they can do a lot of this too. But this is pretty impressive for software again. I can hit spacebar and go ahead and code. You can see it's executing. And in this case, you can kind of see the X is counting down there, I think. Yeah. Right, it's doing some routine, X is counting down, and I bet when we get down to 0, but if I don't want to do something, I can also skip past it, right? Skip a couple routines, and then if I want, I can exit out of the stepper, and hey, let's just go. Let's go from here, see what happens. All right, well, random stuff. In that case, it left the text mode on. So anyway, that's GSBug. I use it for debugging. There's a lot more to it that I'm not going to show. I think you can do some toolbox tracing and stuff like that. Pretty powerful. But part of my project was to kind of recreate that experience with all of this modernization and the API work that I'm talking about. So on the modernization, if you're not familiar with KEGS, the original emulator this all comes from, it's brilliant. I mean, I was briefly looking last night, and I found change notes as far back as 1997. Okay, so we're talking about a 20-year-old emulator. That's pretty wild to me, and it actually was it was almost really just as good back then as it is now. It was just written for a different time. I believe Kent Dickey worked at HP, so of course there was HP UX support, which I'm not going to maintain going forward and you know, X Windows is still a thing on there, and I thought X Windows was great 20 years ago. I don't have any interest in that now. No, I'm not going to. Well, no, it wasn't, but it was neat for the idea of remote displays. You know, they were trying to bring out more serious computing concepts to the desktop paradigm, and I applaud that. It was super overly complex, right? And it still didn't work with a lot of things. Can you do joysticks with X Windows? Anybody know? I mean, probably not unless it's like some serial interface or something, okay? So these things are very old, and it needed some love. So one of the first problems I had was the Mac OS version really only had the X Windows driver. I think that their native frame buffer driver was for some Cocoa thing, like, I don't know. I'm not a super Mac programmer, but it just only shipped with the OS, or with the X Windows driver, and OS 10 doesn't ship with X Windows support anymore. You can download it, but I wasn't just doing, the modernization piece is actually not just for me. This is something I want to do for everybody because I think we deserve a more plug-and-play drop-in emulator. I mean, especially for the GS, it should be super simple that you just download this thing, you've got an app. GSPort is pretty good with that, but I want to take that all a lot further. So to replace X Windows, sorry about my creepy screensaver. To replace X Windows, I needed to write my own display driver. I used SDL, so I'm sure a lot of people are familiar if they're programmers, but basically it's a library called Simple Direct Media Layer. It's a cross-platform development library designed to provide low-level access to audio, keyboard, mouse, joystick, and graphics hardware via OpenGL and Direct3D. What does that mean? It means if I write a display driver for my emulator that uses SDL, I can build that same display driver on OS 10, on Windows, on Ubuntu, on Raspberry Pis potentially. I believe there's a somewhat up-to-date SDL for the Pis. So this is going to solve a lot of problems because if you've ever looked at the KEGS source, each one of those operating systems has one or more builds because some have an X Windows driver and a frame buffer driver. It's like, no, let's just support SDL. It's fine. So I spent a couple of weeks hacking and wrote an SDL2 driver. And I started to slowly add in some things that had been kind of built in over time and then broken and then brought back. So, sorry, John, I have to use your game. This is a copy I pulled off of the internet last night. It's not actually the one I played when I was a kid. Okay, so this is now running an SDL, right? And it's essentially translating it to native calls that work fine on the Mac. I'm going to try and get it ahead a little bit here. And I'll let it load natively. So one of the first things I did was bring back support for full screen, right? That was broken forever. I added support for things like config files, so I could tell it which config file, so it makes it easier for me to solve that hardware problem of mounting disks because otherwise you could only kind of have one config file in a directory, and so now I just kind of I can have one directory that has a bunch of config files. I also, because it's SDL, I mean, doing joystick support was no problem, so you can use it with any HID, right? And same with the audio driver. And there was already, sorry, that was pretty bad gameplay. I should have at least gotten down and gotten to the axe and gotten back up the rope. I mean, but it's hard to walk around. So this was actually not too bad of a project. Yeah, poor guy. We'll just put him out of his mercy. Hey, yeah. So that all works. I mean, and that's out right now on my GitHub as GS+. It's been out for months. Yeah, you still need to build it. But at some point, I will be trying to provide some nice pre-built distributable binaries. But this is all relatively stable. I mean, that works well. And again, this is not my forte. SDL is pretty simple as far as the calls. And I made some changes. You know, he had optimizations back in the day to only do updates in certain parts of the screen that it assumed had changed. Like, oh, I see you updated the bottom 4 rows of the text, so only send that out. And I just send all of it out every time because it's 2016. And I don't think it's probably an anti-pattern where you're making multiple draw calls instead of just sending one giant like blit call, right? Because that's what it is. It's a blit call in SDL that says, take this chunk of memory, put it in your screen chunk of memory. So I did make some changes, but it all works really well. I was kind of surprised, actually. Yes. The one last hard problem about sort of modernization and bringing in people to this project, which I don't want to do. I'm kind of okay with me doing it for now because I am doing weird stuff now. But I do want it to be a project that if somebody wants to fork and do their own thing, they don't have to spend 3 days figuring out how to build the darn thing. I'm sick of projects like that. Or, you know, the guy who maintains it really only does it on his Mac. And he doesn't care about the Windows or Linux builds. It's like, again, it's 2016. I think it's not that hard. If I can do it, seriously. It just, you have to spend a little time up front and then you just maintain it, right? If you get those builds working, your goal is to keep them working and not neglect them. So that actually goes exactly into what I do about this, how I maintain sanity and still can provide that kind of support, right, across platforms. So I commit to GitHub, public repository, very well known, so I'm not going to rehash that. But at home in my basement, there's a super abused server with a video card that has a fan that's seized up. And it is my, don't worry, it gets backed up, because I don't really care. It runs GitLab, which is essentially like GitHub, but it's a private server. So I push things there because GitLab has something called continuous integration. It means that every time I push a commit out there, it's going to try and build all of the different versions that it thinks it knows how to build. Actually, it doesn't do that. It says, hey, all of the different build robots, I got a new version. Would you pick it up and build it, and then give me your, you know, sort of response? So, oh, and of course, I forgot to set up the internet, right? So I may not be able to show you if, oh, I'm on, okay. I'm not sure why that is going so slow. There we go, yeah. Yeah, I thought for sure. Yay, it's like KeyPass, but cheaper and less secure.
Firefox will actually remember that, unlike the other browsers. Chrome will remember it too. Oh, will Chrome do it? Yeah.
You don't like my ASCII text file called Rockhurst in my home directory? That seems like...
I wouldn't say it's your most impressive one.
It's good for a week, right?
It's good for a week.
Yeah, all right.
Good job.
We'll try this again. So again, we're going all the way 5 minutes across town to Dagen's basement. Yes, for those that don't know, I do live in Kansas City, fairly close by. Okay, so you can see it looks like GitHub.
Invite us over.
Yes, I got one of those above ground, like 12-foot pools. You can come in with me and the baby. He's got his own little floaty in there. So when I commit, you can kind of see a history here of some different commits that I've done, and some of them, have a scary red X, and some of them have a nice green check mark, and they say passed. What does that mean? It means that, again, I had been working on code, I'd been committing. At some point, I pushed it to my server in the basement, and here's what it does. It tries to do all these builds. There's the new SDL version that I've been working on. There's a legacy Ubuntu SDL version. It was super easy to do an SDL2 version. I just plugged my driver in, it worked. I haven't done one for Windows yet. I still do the Ubuntu X version and the native Windows 32 version. So again, when I commit, if I broke something on Windows, I know within a minute. All right, this is how I plan not to leave behind platforms and just hopefully avoid that whole problem, because I don't think it's avoidable, and that's where my DevOps background comes in. I just want to make sure that let's keep it stable. I don't want this to look like a totally half-baked project. It is still at this point half-baked, but it's getting there. So yes, I've got this was really a big turning point. I got the emulator cleaned up. I had SDL working. I had gotten some things working that had been deprecated for years, like I can paste text into my emulator, right? A la, your virtual box or parallels type of stuff. I don't really use that, but if it's there, I should make that code active again. And I was able to do a lot of that. But what I really wanted was to add a better debugger. I wanted one with a nice graphical interface, but I, again, didn't want to have to support different code for each OS. So to do that, I had to think outside of the box. But we're going to come back to that later. So before I go any further, I just want to ask, are there any questions? Is anybody? Yeah, go for it, Evan.
So if I understand correctly, this is derived directly from KEGS, not from GSPort, correct?
No, this is from, if you look at my GitHub repository, I've kind of been forking KEGS for years, and then starting for a couple weeks, and then going, eh. So my repository has been around for years, but what I did this year was basically go pull whatever the latest GSPort was, maybe pre-Christmas, so it might have been last year. I can't remember really when I started this. It's probably committed somewhere. And the main reason is that, so I don't think the core has really been improved or enhanced that much. There's, I mean, you can look through the, anybody here a C programmer? Like have a little familiarity? So you know what if-defs are? Holy crap. Well, if you're Windows, do this. But if you're Mac, do this. Unless you're ex-Windows Mac, then do this. And it's just, yeah. So they didn't really change the core. What they did is they sort of built more of those drivers in. They did it through more if-defs. I would have tried to break it out into larger chunks, and I have done that somewhat. But
But because it is derived from GSPort, it has like the internet emulation.
and that's why I wanted GSPort, because what they did add was enhanced functionality like some Apple Talk support, some Ethernet support, so why throw away that work or try and go grab it later after I'd already kind of moved on. So granted, I had to, I think I broke a couple things in the build for that, because some of them depend on external libraries that I was having a hard time building, and I got the core back to where I needed it. So that's kind of one of those things like doing the Windows SDL version that I've got to go back and catch up on. So that's just one of the many sort of loose ends that I still have yet to clean up. Again, super experimental stuff today, and all of this is going to come from the same emulator. Creepy. Okay, any other questions before we go on? Oh, refactoring tools? So I did actually write some of the SDL driver in VI. Sorry, guilty pleasure. And it works. And it's fast for me when I can be in a single file, couple files. This is a large project. It involves a lot of headers and C files that I don't know where they are. So I used Atom, which is open source, and it's essentially, what's the other, Sublime? It's a lot like Sublime, except it's kind of an open source competitor. I think it may have started off slow, but it's really stable now. There are things like 6502 and 65C816 assembly plugins for it. But really the main thing is I had to, at that point, have like global find and replace, because yeah, that's what I was doing. I'd go in and say, replace this one variable name across 30 files. And that's not something I really do in VI or command line. Like, it's too easy to use just a modern text editor. But that does bring up an interesting point, that another one of my philosophies around all of this is that, yeah, I'm using Git. That's kind of something I'm okay with. Some people have, you know, religious arguments over their source code repositories, but just use one. But there's a couple, oh gosh, now I can't remember. Yeah, maybe I'll, all right, sorry. All right, anyone else? Ivan?
To the extent that there's a functional Mac version, if one can build it or you can build it, does that mean that Ethernet emulation and Apple IIGS are now available in a Mac build of the GS emulator?
If I didn't break that?
Well, it never worked on GSPort. It does not work on the Mac. So,
I don't know, because I haven't really gone further than, so if you think about it, really what I have touched is the media layers, input and output,
okay.
and that's really specific to mouse, keyboard, joystick is a separate one, and then an audio driver and a video driver.
Likely to have changed at this point.
Unless I broke it, which is quite likely.
Okay.
I mean, I'm sure I broke a ton of stuff. If you're not doing that, you're doing it wrong, right? So. So, I think I lost my place here. Did I lose a page? Yeah, I did. That's weird. All right. But you saw my my build environment, and so I want to get into the more advanced stuff, and I've got about 10 minutes, and I'm going to try and go very fast, which is too bad, because this is really the special sauce that's new. Like I said, I wanted a debugger. I didn't want to clutter up my program, and one of the reasons is I don't like some of the sort of programmer UIs that people design where they have just wonky icons and things. So I thought a better way to sort of think about these emulators is like a virtual machine. Who's familiar with VirtualBox? Okay, you start a computer up. Well, you do define a computer first. You say this computer has a 100 gig hard drive, 4 gigs of memory. It's got a screen this big. It's got, you know, these different things. It's going to run Windows. You click launch. It starts. All right, and you can do things with it like pause it. You can shut it down. But whatever you've been working on is saved in there. Like, it's got this idea of state. It really treats it like a little computer in a bubble. And again, I think that we're treating emulators like an application. We should be treating them like these little computers in a bubble. So the first thing I did was try and come up with an interface for that. And remember, I put in a command line switch to be able to pass configs. And to do something useful with it, I made this front-end program in C++ using Qt, which is a UI framework, right? You can write Windows, Mac apps. The goal of Qt is that I can build it anywhere. I should be able to actually build this for Android, potentially. I'd probably have to change all of the layouts. I'm actually using like a visual layout tool, It's not bad. Actually, I prefer it much to Xcode. Oh man, this is so much better than Xcode and Objective-C. Anyway, I just have to slam that every talk I give. So what you can see here is I have this list of virtual machines, right? And remember I had those project directories, and that works great for my projects, but I'm thinking more about, you want to play, well, you want to play Rastan. It's got a bootloader. A lot of things have custom bootloaders. Module is a demo by FTA. And so what I've done here is got that same idea of each one of these represents a virtual machine with a config of its own. It has its own idea of how much memory this machine has. So it could have 8 megs. It also has an idea of what its border color was the last time it was used, all of the things that are in battery RAM. Right, and that's what you get out of the general KEGS config file. So I'm not going to lie to you, there's a little bit of smoke and mirrors here. I don't have a full editor where you can go in and set your hardware config. You still do it the way you do in KEGS, either through, there's a built-in interface, or you can edit the text file directly. Oh gosh, I probably shouldn't run this because I'd rather turn it down. So, you run a machine, it's just typical whatever. And this is still the same emulator with SDL and everything. Works great. And the main system here, it knows it's running. It's actually launching it externally. It's launching that emulator. These are 2 separate programs. So it doesn't really know what the other one is doing. And I'll get into that, but already we've got this cool launcher. I can do things like all of this wiring already works, so I can say, hey, let's copy this one and go ahead and edit it. I got that config for Rastan sitting out there, and so let's go find where I had that. Oh, there it is. Okay, boom, great. Launch that, boom. So now I have a different computer that's pre-configured to run Rastan every time. Right, not bad, copy paste, all that it works. Most of it's the wiring built into Qt. I can do things like rearrange them, and I have it save it on exit. So this is a real app. I haven't released it. It's, probably not a bad idea to do so, but I'm still doing this other experimental stuff that I'll get into. But just as one more demo of it, what's neat about Module is that it ejects the disk at the end, which doesn't help me because I don't want it to eject the disk. So here's Alien Mind. See, when I did this demo before at home, I had a much bigger display space. But what you can see is I'm launching all these emulators. They're all running simultaneously thanks to the magic of SDL. They don't have a problem generating audio and sending it out simultaneously, so you can get this glorious cacophony of 7 emulators running and doing random things, right? So that's just really the launcher piece, which is, I think, a good way to get started, but eventually I would like to flesh this whole idea out a little bit more. But again, remember I said it launches it, and I think we're good because we're getting into the last demo. We're launching it, but there's no real communication between these 2 programs. So I have to give this launcher, well, it'll become more than a launcher, but I have to give it some way to see into the emulator, and vice versa. I have to give that virtual machine the ability to communicate out information about itself, about its state. So I had some ideas. One idea would be to build the emulator into the launcher, at like a child process, or maybe separate threads or fork or something. And all of those seem like really bad ideas. If some of you think I missed an opportunity there, let me know. But one of the reasons is that you're more tightly coupling some goofy launcher that maybe somebody doesn't like with your emulator, and I don't want to do that. I want to keep that emulator still pure. It can still run as command line like we did, If they don't like my launcher, they can actually make their own launcher. They can make launch scripts. They can do whatever they want. I'm just providing the functionality through things like command line switches so far. So then I had the idea of, well, in computer science, which I know nothing about, we have this thing called IPC, inter-process communication. And that's just the general term for it, right? There's a couple different ways to do it. There's shared memory. Let two programs access memory. That is probably not something I should be trusted with. I mean, I'm not a full-time systems programmer. I wish I could. On an Apple II, I could, right? Like, that's the order of the day, but on modern operating systems, I don't know that I could do that correctly. I wouldn't mind learning. And I thought that would be great because it's inherent speed advantage, right? You're pretty much talking to the metal. Both guys are looking at the same memory. There's things like pipes. Of course, pipes are another inter-process communication concept, but they don't work the same on Windows because, of course, nothing does. Domain sockets don't exist on Windows, which is another beautiful idea. And then it kind of came down to the last sort of lowest common denominator, which is why not regular sockets, TCP/IP? Does it really need to be that fast? We are all of a sudden decoupled. I don't have to even be on the same machine. This launcher can be on a different computer, right? And I can launch things somewhere else and remotely connect to them if I use TCP/IP. So that's what I did. And how fast does your things like the breakpoints need to happen? The emulator is going to break when it needs to break, and there can be some latency there. So 2 minutes, counting down. So how does this work? We make the emulator our virtual machine. We make it into a server. And then we take this launcher and we add the functionality of a client. Then we can add all kinds of other functionality, starting with the full remote debugger. So again, what I'm saying is this. If I do GS+, which is the official name of my fork, okay, I'm going to give myself 2 terminals here, one to run the application. Okay, so I started GS+, but it has not done anything. Why? Because I said you're now running as a server, listen on port 8000. We all know how web servers work, right? So where is GS+? It's running. The machine, it has been zeroed out or initialized to the way that a GS would actually be right at the moment before the processor gets control. It's essentially been powered out and halted right before the first instruction executes because it's listening, it's waiting for me. So I'm going to talk to it, and I have a very, very simple API, and I can explain why. Pick the right port, of course. It says, hey, somebody connected. Getting exciting, right? This is the big finale, you guys. I enter 1. That is my API command for hello. Okay, so what's happening? It's running. It spit out a bunch of stuff. All right, and this is just a goofy little test program. And it's running really like the normal KEGS is back there. You can see it does that same thing it always does, spits out grind, 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 and everything like that. What's all this other stuff? Well, for those of you programmer heads out there, it's JSON, right? I don't think I can show both windows. I'm going to do this just for fun. Remember, this is our telnet terminal down here. I'm gonna tell it to kill itself. All right. Instead of killing the application, I just sent a message through to the server. So that's neat. And I built a very simple API around that. And I'm going to launch that same image with that same test program with a sort of a debugger built around this idea. Great. So it has some sort of goofy semi-junk info. It got some info when it sent the hello command. It got a response back in JSON. So I'm going to hit step. It sent a command 3. Again, a super simple API. It sent the number 3 to there, which says take a step. Actually, it says halt and wait for your next step. When it does that, and I can go show you over in Qt where it actually still has the console output. it sent all this stuff back. What did it send back? I wish I had a example already pasted so you could see it in a formatted way, but I can explain it in here. It sent back the stack on the left. So when I said step, it halted the processor and said, here's what the CPU looks like. Here's all your CPU registers. Here's where your stack is currently looking at. And here's your next 10 lines of disassembly. And so if I click step again, it actually takes a step. Ooh, and it's colorized. And if you look down at that CPU down there, what are we doing? We're decrementing Y, all right, as we're trying to write data to that graphic screen. You can see it counting down. So it works a lot like GSBug. I can also skip. Skip works a little differently. What skip does is it sends a message that says, it basically looks at what it has in the program counter. It looks what it has for the disassembly and says, well, what's the next line? What's the one after that? All right, 208C, we'll send this over to the emulator. Emulator, go to 208C, and internally it knows that it just skipped it, so it marks internally, I skipped that line. So you can have neat colorized stuff. And I may change how some of this is laid out. I do have a tool to just get arbitrary memory banks and edit them and send them back. And as you can see, it's essentially a huge JSON with a, looks like a bunch of A's, right? This is base 64 encoded because I'm trying to keep the format as JSON. Why does that matter? Why do JSON anyway? And why make the API so simple? So on this client side, I wanted to provide an easy to read format. You can take this and run any script, right, and parse JSON. Every language has a JSON parser. So if you didn't like my launcher, again, you could write your own and have a client that takes back the JSON and does something with it. So what kind of things could you do with that? Why does all of this matter? What is the big advantage of doing this over a regular emulator? Right? It's about automation, it's about tooling, it's about doing a lot of powerful things that you can't do with real machines. So here's an example. I could have 7 programs running on 7 laptops, pulling back all of the different display pages of my emulator every, let's say, 60th of a second, but that probably would be a bit of latency, so you might want to say just once a second, pull all the memory. And each laptop could show, one could show low res, one could show double low res, one could show high res, right? And those laptops could be anywhere in the world, and they could be displaying the display pages of this. Why would you do that? Well, I don't know for that example, but I can give you an example I would use. I could create a continuous integration test bed of emulators with different hardware settings. I could have a ROM1 GS, a ROM3 GS, one with 1 meg, one with 4 meg, all possible combinations of those. Okay? Then what I can do is I can start them all up at once, have them run to a certain point, control all of their inputs, you know, keys, mouse, have them stop at the same point in execution and send back their memory, stack registers, etc. Compare that. This is extremely helpful for automated build testing of complex projects, like GSOS, for example. Random, totally random example, right? But let's say you wanted to test something like that across a huge different amount of configurations, and now have a way to do that and really precisely control it every time, and get the same thing I get for my Apple II software that I get for this software. When I push it, it says, hey, you broke the ROM3 that's 1.25 meg. So I go back and I fix it, and everything gets tested again, and it's like that, and I don't do it. I know another fan of automation here, you know, again, cloud stuff, you could run emulators in the cloud if you want. Why? I'm not really sure, but if you had shared input, you could have a multiplayer game that sends back the display to both players, responds to their input, and that might take a night to put together. I mean, I'm not kidding. It may be not having the sound, but I mean, that's pretty much there right now, minus some of the inputs. So there's limits to a lot of these, especially with things like the latency and sending this data back, but I really think this is kind of the tip of the iceberg for this technology for me. I'm going to try and push it. I would like to hear from people that maybe have more experience in this, but you can, another example is you could have it automatically grab screens from different programs, like load disks, grab screens, mash keys, wiggle mice, take screenshots and turn them into animated GIFs. I know. If you were running something like, say, an Internet Arcade or Archive, yeah. So the only things, to fully flesh out this idea, because I'm out of time, I still don't have things like save states. I need the ability to tell the emulator, pause, like save everything, all your registers. Yeah, it's probably not going to be incredibly hard, but it's all, each thing takes a couple days of hacking. So, input and output, the API does not currently send in things like keystrokes in my stuff. Totally can. You can see I have the ability to control it remotely. So right now I'm just sending in remote things for my debugger because that was what I really wanted. But I think I will try, and if I can do the integration, start sending in other types of data that might be interesting. Because that's what I can do now. I can inject data anywhere. I can inject data directly to the super high res screen if I want, for whatever reason. I would like, right now it's a single client, so only one person can technically connect at the same time. More than one person can connect, but it leaves a dangling pointer, so we'll not talk about that. But I would like to make it a true multi-client so that more than one person can control it, or again, maybe 3 of us in a different part of the world are doing build testing and we all want to look at the super high res screen at the same time. I can go, here, look, watch when I do this, it crashes. And they see my mouse moving, they see what I do, they see the crash. So what's left to do aside from that is I do need to improve the integration points for the server a little bit. I'm not a TCP server expert in C, so I'm not waiting on a thread to tell me I got something off the network. I'm polling, and I set it up to poll with the 60 hertz refresh right now of the emulator. So I'm polling and going, do I have anything? Would it block? I'm using non-blocking sockets. If it would, then let's just come back later. And so it's, I think, impressive to me that I was able to do it, but I'm sure it could be done better. And then I still want to go back and improve the core emulation of KEGS and make it more accurate and fix a lot of things that are just so close, like border effects, but have a little bit of wonkiness. I'd like to get the Ensoniq emulation rock solid. There's some other Ensoniq emulators out there now for the 5503, so maybe I could go look at their code. But again, I have my own mad science stuff integrated in here, but I do want to eventually come back around and provide a rock solid emulator for the community. So that's a good 10 minutes over my time. I don't know if I'm going to get kicked off right away. Do we? Yeah. Sorry. So obviously feel free to talk to me about this because I spent a lot of time on it, and I appreciate everybody coming down and taking a look.